How do we know that it's from alkane group? This is because it is only single bond that you can see here. Remember that there's what we call homologous series and functional groups. In homologous series, we say it is families of organic compounds. And one of the families of organic compounds we have is alkane group. So how do we know alkane group? The functional group for alkane group is that you have single bond all through. As you can see, there's no double bond, no triple bond, no other functional group in this. So it's only what? Single bond you can see. So that is why we name this naming of alkanes. Now what do we do so as we can name a given alkane very well? For you to name a given alkane very well, you have to check the longest carbon atom. Then as you check the longest carbon atom, ensure that the substituents you have, that the sum of it will have a lower number. As you check out the longest carbon atom, ensure that the substituents you have will have a sum of lower number. See what we mean? You know that when we count like this, 1, 2, 3, 4, 5, 6, 7, 8. This gives us 8 carbon atoms. Once we count like this, 1, 2, 3, 4, 5, 6. This will give you 6 carbon atoms. Then once you count like this, 1, 2, 3, 4, 5, 6, 7, 8, 9. This gives you 9 carbon atoms. That is the highest we can get. We say this is named as first carbon, second, third, fourth, fifth, sixth, seventh, 8, 9. See how we numbered it. We numbered from this to this. But let's check the substituent. If you follow from this part to number it, you notice that the substituents will be on 4. We have 2 substituents on carbon 4. Look at carbon 4, and it has 2 substituents, 2 methyl group. So we have 2, 4, 4 plus 4. Then at carbon 5, we have another substituent plus 5. At carbon 6, we have another substituent plus 6. Okay? Even at carbon 5, we have 2 substituents at carbon 5, which is methyl and propyl. So we have 5 plus 5, 2 substituents here. Then at carbon 6, we have 1 methyl, we say plus 6. You now check out what will be the sum. That is why we say, as you get the longest carbon chain, get their sum and check the one that the sum will be a lower number. Now, so what we do? 4 plus 4, 8. 8 plus 5, 13. 13 plus 5, 18. 18 plus 6, 24. This gives you 24 following this route. Now, you say again, let me check opposite. Carbon, this will be carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, carbon 7, carbon 8, carbon 9. Now, following these routes, now let's see what it will give us. At carbon 4, 1, 2, 3, 4. At carbon 4, we have 1 substituent. You write 4. At carbon 5, we have 2 substituents. 5 plus 5. At carbon 6, we have 2 substituents. We have 6 and what? Another 6. So we now add it up. 4 plus 5, 9. 9 plus 5, 14. 14 plus 6, 20. 20 plus 6, 26. You can see that following this route, which is the longest carbon chain, gave us 24. Whereas following this route gave us what? 26. So we say we will follow the one of shorter route. So the one of shorter route gave us 24 sum. So we now say we follow this route. So we now say we will not follow this route. Instead we follow this route. So we now claim this second naming or this second numbering we have. This is 1, 2, 3, 4. Then this is 5. Then 6, 7, 8, 9. So why did we follow this route? We say it's because he gave us a lower sum. You know that sum is the answer you get after addition. So this rule gave us a lower sum via the substituents we have. So the substituent 4, two substituents fall in here is at carbon 4. You write 4 plus 4. Two substituents fall in at this carbon, methyl and propane. You write 5 plus 5. One substituent fall in here, you say plus 6 because it has carbon 6. So when you add it up, it gives you 24. But if you number from this side and add up the position of the substituents you have here, it will be giving you 26. So we don't need the higher sum. We take the lower sum as the rule tells us. So what you now do now, how do we number? Now, how do we name? For you to name, you must consider the alphabets we have in English language, the letters we have in English language. You know that the substituents we have here are methyl, propyl. Methyl and propyl are the substituents we have here. Methyl and what? Propyl. Now, from letters of English language, we must say M before P. Yes, because we must say M before P, we now say this M will come first. We now say, where do we have M? We have 2 M at position 4, 1 M at position 5, and 1 M at position 6. So see what I will write. The one at position 4, I will write this first. 4, because we have 2 M at position 4. Then at position 5, do we have another M? Yes. Look at methyl at position 5. Please, as you write the numbers, please put comma. At position 4, we have 2 methyl. We write 4, 4. We say this is because we have 2 methyl at position 4. We go to position 5. Do we have any methyl there? Yes. Only 1 methyl is what we have. We say 5 methyl. Okay? At position C, we have another 1 methyl. We say another 6 methyl. So we are taking care of the substituents called methyl in this structure. We now say, how many methyl do we have? 4. Because it is 4. When it is 1, you say mono. When it is 2, we say di. When it is 3, we say tri. When it is 4, we say tetra. When it is 5, you say pentyl, and so on. So because it is 4, you say tetramethyl. Tetramethyl is that tetramethyl means that you have 4 methyl group in this structure as substituents. Then after taking care of the methyl group, remember we have propyl at this substituent, at this point of attachment. Then you now say 4, 5, 6 tetramethyl, then 5 propyl, because propyl is at carbon 5. We say methyl and propyl are the substituents we have here. So propyl is at carbon 5. We say 5 propyl. Now, what is the highest carbon chain we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 carbon atoms. Then we now say, when it is 1, you say methane. 2, ethane. 3, propane. 4, butane. 5, pentane. 6, hexane. 7, heptane. 8, octane. And 9, nonane. So because this is 9, we now say propyl nonane. So that is how to name this structure. 4, 5, 6 tetramethyl means we have 4 methyl group at the attachment, at the point of attachment. Then 5 propyl means that we have 5 at the attachment of carbon 5. Then nonane means that the longest carbon chain we pick, the highest is 9 carbon atoms. So that is how to name this question or this structure we have in alkane. Thanks for watching the video. Please don't forget to subscribe to my YouTube channel and like my video. See you in the next class. Thank you.